Hey learners, welcome back to another session. Here is a brief explanation of fluid mechanics, thrust and pressure and their applications. First, we are going to talk about thrust. It is the force that acts perpendicular to the surface of an object. It is measured in newtons. N. For example, when you push a nail into a wall, you're applying a thrust on the nail. Thrust is also the force that moves an aircraft or a rocket through the air or space by overcoming the drag. And the weight of the vehicle pressure is the effect of thrust per unit area on an object. It is measured in pascals PA, which are equal to newtons per square meter, and m squared. For example, when you cut your nails with a nail cutter, you're applying a high pressure on the nails because the area of contact is very small. Pressure is also the force that a fluid exerts on an object that is immersed in it or on the walls of the container that holds it. The pressure of a fluid depends on the depth, density, and gravity of the fluid. Some applications of thrust and pressure are school bags have wide straps to reduce the pressure on the shoulders of the students. Sucking a cold drink through a straw creates a low pressure inside the straw, which allows the atmospheric pressure to push the drink up. T-fluid. Thrust and pressure are the basis of the Archimedes principle, which explains why some objects float or sink in a fluid and how much buoyant force they experience. Now we will be learning about density, relative density, buoyancy, and Archimedes' principle. Density and relative density are two concepts that describe how much mass a substance has in a given volume. Here is a simple explanation of each term. Density is the mass of a substance per unit volume. It is calculated by dividing the mass by the volume. The unit of density is kgm cubed or gcm cubed. For example, the density of water is 1 gcm cubed, which means that 1 cm cubed of water has a mass of 1 g. Relative density is the ratio of the density of a substance to the density of a reference substance, usually water. It is also called specific gravity. It is a unit-less quantity, which means that it has no unit. For example, the relative density of honey is 1.42, which means that honey is 1.42 times denser than water. You can use the following formula to calculate the relative density of a substance Rd equals sign density of substance. 1 divided by density of substance. 2. Some applications of density and relative density are density can be used to identify different substances, as each substance has a unique density value. Relative density can be used to determine whether a substance will float or sink in a fluid. If the relative density is less than 1, the substance will float. If the relative density is greater than 1, the substance will sink. If the relative density is equal to 1, the substance will neither float nor sink, but stay at the same level. Relative density can also be used to measure the purity or concentration of a substance such as gold, milk, or alcohol. Now, buoyancy and buoyant force. Buoyancy is the tendency of an object to float or sink in a fluid. Buoyant force is the upward force exerted by the fluid on the object. The buoyant force depends on the density of the fluid, the volume of the fluid displaced by the object, and the gravitational acceleration. The concept of buoyancy can be explained by the differences in pressure acting on opposite sides of the object immersed in the fluid. The pressure in a fluid increases with depth, so the bottom of the object experiences more pressure than the top. This results in a net upward force on the object, which is the buoyant force. Some applications of buoyancy are ships and boats float on water because they are designed to have a lower density than water. They displace a large volume of water, which creates a buoyant force that balances their weight. Submarines can control their buoyancy by adjusting the amount of water and air in their ballast tanks. When they want to dive, they fill the tanks with water, which increases their density and reduces their buoyancy. When they want to surface, they release the water and fill the tanks with air, which decreases their density and increases their buoyancy. Hot air balloons float in the air because they are filled with hot air, which has a lower density than the surrounding cold air. The hot air displaces a large volume of cold air, which creates a buoyant force that lifts the balloon. Now, Archimedes' principle. Archimedes' principle is a law of physics that describes how a fluid exerts an upward force on an object that is partially or fully submerged in it. The upward force, also called the buoyant force, is equal to the weight of the fluid displaced by the object. The principle can be used to determine the density, volume, or mass of an object by measuring the buoyant force and the weight of the object.